Okay, I'm going to do an example here of an applied problem involving a linear equation. I'm in section 1.4, page 44 in the textbook, and problem number 75. Sales of GPS equipment. The annual sales in billions of dollars of global positioning system equipment from the year 2000 through 2006 follow. Sales for 2004 to 2006 are projections. Here, x equal to 0 corresponds to the year 2000. And part A says to plot the annual sales, y, versus the year x. And that's what I've done with the table of values there, annual sales being the y values, and then the year being the x values from the year 2000 to 2006. I've plotted each one of those points given in the table into a graph. And again, when you're applying the algebra to a real situation, it's good to go ahead and label your coordinate system. And you notice that in my horizontal axis, my input variable there, or my independent variable x, is the marks the years, the input of the equation, and then the annual sales in billions of dollars will be the output. B says to draw a straight line through the points corresponding to 2000 and 2006, so that's what I'm going to do now. So I've got my line through the points, and if you recall from earlier lesson, to try to get the equation of a line, notice that this line doesn't really go through all the points, but a linear equation or function ultimately is going to be a good approximation of the relationship between x and y. I'm going to pick 2 points on the line. Again, that's important to find the equation. I need at least a couple points. I'm going to pick the intercept point down there at 0 and 7.9, and then the point 6, 18.8 I'm going to use as my other point to develop my equation. So the first point is 0, 7.9, and then 6, and then the 18.8. Now there's 2 things that I need to get this equation, and one of them is the y-intercept, but I have that. The y-intercept is 7.9, and then the slope. Now to get the slope, I'm going to look at the rise over the run, and I can see from my slope formula, I'm going to take the difference in the y values over the difference in the x values. And that would be 18.8 subtract the 7.9 divided by 6 subtract 0, which would be 10.9 over 6, or 1.82 will be my slope. And the y-intercept, I already have that at 7.9. So really the best form to get my line here, since I have the y-intercept, is just use y equals mx plus b. So my equation would be y equals 1.82x plus 7.9. And this would be the equation that would express the relationship between the variable x in years and then the variable y, or to the variable y, annual sales. In part D, it says use the equation found in part C to estimate the annual sales of GPS equipment for 2005. Compare this figure with the projected sales for that year. So in part D, to get the annual sales for 2005, which is represented by x equal to 5, I'll plug in 5 for the x and then solve. So I get 17, or the answer there would be 17 billion. $17 billion.